Where's the electronic I want? Do you having problem organizing your electronic or finding the parts that you need in the organizer? If so, you are not alone, but I don't have an organizer. Imagine if you have hundreds of thousands of categories of electronic with different values that you need, but you never know where the location is. Wow, that is such a tragedy. So in this video, I'm gonna design a simple smart electronic organizer to organize my electronic, and I think it might help you. After several fine-tuning and 3D printing try, I finally get the design I wanted, and they turned out excellent. So let me show you how I design the 3D parts. So head over to the OnChef software. Again, I'm using the OnChef software to design the smart organizer because I think it's easier to make a design. And this is the drawer I designed. So what I want to do is store as many electronic parts in the organizer as possible. So as you can see, the container is 3 by 3, which means it can store 9 different categories or different values of same category in one container. One thing I want to mention here is the sharp fin at the end of the container. Its function is to stop the container from sliding out when you take out the drawer. Also, I designed the snap fit mechanism as you can see here. The snap fit mechanism is useful when you want to join two parts together. So this is the top parts of the container and this is the bottom parts of the container. So there's also a snap fit mechanism as both sides to combine the top and bottom parts together. And this is how it looks like when two parts snap into each other. If we go over to the section view and see it from the side, we can see the snap fit mechanism is very tight. And the third part is the main organizer itself. As you can see, there are only one row with two columns. I can do for 3 columns because 2 column size already reached my 3D printing bed size. And this hole is to put some LED strip to do the effect. We can also see the snap fit mechanism at the top and the bottom of the organizer. So if you want to expand the row, you can just snap 2 organizers together and you have 2 rows with 2 columns. It looks like when all parts assemble together. We can see from the section view to see how it looks like from the inside. You can see the sharp fin really does the job for prevent the container from sliding out, and the snap fit is really good. So as you can see here, the sharp fin, and this hole is to let the LED strip wire come out from the container. So that's the overall design of the smart organizer. So I'm gonna talk about how to print the organizer in case you want to print the same quality as me. You can pause the video to follow the whole setting. So the layer height is 0.15mm and the line width is 0.4mm and the wall count is 1. So it is very thin. And the infill density is 5% only, so it is very less. So I'm using a 3 support. And the printing time is 1 day and 22 hours. So you need to print 2 days. For another 2 parts, you can print with this setup. So the layer height is also 0.15 mm, line width 0.4 mm. The other is the same, but the wall line count I increased to 3. So the other thing is also the same. And the infill density I increased to 30%. But there is one thing I add for these 2 parts, that is the fuzzy skin setting. If you don't know the fuzzy skin is the noise applied to the surface of the 3D printing. In simple words, it adds the texture to the surface. So here is the result. As you can see, the quality is really good. It is tough and it's beautiful. You can see my hand at the behind. After you put the LED strip here, you can snap these 2 parts together. So let me show you how. So as you can see, the snap is very tight. But you cannot snap too many times, otherwise it will break. So make sure you snap the organizer after you've done everything. And you can feel the fuzzy texture is really satisfying. And the organizer has finally printed. I will insert it to test whether it's fit or not. Wow, perfect fits. You can see the shark fin is really works.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
So it's time to design the hardware. So head to the schematic. I'm using the EasyEDA to draft my circuit. Everything already pre-tested, and this is my finalized schematic diagram. At the top, we have some DC filter, and we are using the Wemos D1 Mini with ESP8266 microcontroller. I'm using this, but you can use any other IoT device. And we have the joystick for simple control, but as you can see, I only connect to the x-axis of the joystick to A0 because the Wemos D1 Mini has only one ADC. And the joystick switch is connected to the D6 with pull-out resistor. And we have the buzzer connected to D5. And we also have the mini OLED screen for display some result or message from the IoT. And we have 3 LED strips connected to D3, D7 and D8. Just now I have mentioned about the design only support 1 row and 2 columns. So the LED strip is also the same, 1 for the row and 2 for the columns. And this is really important because you cannot use the same power supply from the microcontroller, because each of the LED will consume 20 mA current. So when you have large number of LEDs, the microcontroller will easily broken because microcontroller is not designed for power supply. And that is the reason I put this circuitry here. And this is just the terminal block and some filters. I already soldered off the component based on the schematic diagram, and this is how it looks like. Since each of the container has to have 9 LED, so I have soldered the LED for each container individually. Before you crimp the ferrules to the wire, you have to pass through the wire through the hole first. So now you can crimp the ferrules to the wire for a solid connection to the terminal. Then fix the LED strip in place according to each of the box position. I'm using the hot glue to fix the position because I don't believe the tape will last forever. Now let's test whether the soldering is solid by using the Adafruit NeoPixel library to test the LED strip. So I'm using the standard test. So change the LED pin to the pin we use. So I'm using the D8 and define how many LED have been used. Since the container has 9 boxes, so change it to 9 and upload the code to the Wemos D1 Mini. Now let's connect the LED strip to the board and the external power supply and on all the power supply. Wow, this is really unexpected. It's very beautiful and I couldn't say a word now. So let's enjoy this moment. I have modified the standard test code to let 2 LED strip light and add some electronic in it. Open the Arduino IoT crown. I first create a device and set out the device you are using. You must remember the device ID and the secret key. Then I'm gonna create the thing and name it message. The variable type is character string because I'm using the messenger widget and it tells that it can be linked with a string variable. And you can clear the message widget window using the code below. And I set the permission to read and write and update policy to on change. Then I associate the Wemos D1 Mini that I just created. Then head to the dashboard and create a messenger widget. Link the variable to the variable we just created. Back to the things menu, you can see the sketch has been automatically created by the Arduino IoT crowd. I choose to download the sketch and modify it in my desktop. Go to the things property header file and modify the SSID, password and device key accordingly. And now you have successfully created the Arduino IoT crowd in your project. Then upload the code to the organizer and type the category and the value at the dashboard according to this format. For the capacitor, it will be slightly different. As the position is correct, it will show the position of the component in green light. And if it is wrong, the LED strip will become red. So that is how you find the component in the organizer. Of course in future this is gonna be more compact and beautiful, but now I just want to store some of my components. Maybe I will design my own custom web interface and change the old LED to the touchscreen display. Probably I'm gonna add the AI and voice assistant too. Then I don't need to be manually input the name and the value. I could just say it loud and the assistant will find it for me. There's a lot of potential in this project, so stay tuned for future upgrades. Make sure to check out the video description to access the schematic, coding and tutorial on how to make this project. If you like the content of this video, don't forget to press the like, share and subscribe button. See you in the next video.